Kicking off this episode is warming up our brains with Ben. So Ben had a pretty interesting take on this for this episode.
I thought I'd change it up a little bit, and I'm going to quiz you guys. So I hope I don't embarrass you. But I have 5 different malfunctions that have to do with 3D printing. One of them's a little bit of a curveball, and I think you'll know which one that is. But I want you to tell me what you think went wrong, like what do you think the issue is. If it has a name, tell me the name. I don't know if they all have terms. And then tell me what you would do to fix it or prevent it from happening again. So let me just pull up my PowerPoint. I can't remember where I put it.
We're doing this live. We haven't seen any of these issues before, and I think what we should do is we should alternate who answers first, right?
Sure. Okay. Do you guys see a white screen?
Mm-hmm. Yes.
What in the world is this?
Ooh. That's Kevin a terrible looking print. Ken, you take this first one. I'll answer second.
Yeah, I see a lot of stringing and probably a bit of under extrusion. Because you can tell by the bubbles, it looks like there's bubbles in the print. That usually means that there's not enough material being printed. And then obviously the wisps everywhere is just, usually that's when when the head of the printer moves from one area to another without actually printing any material, and you get a little bit that oozes out as it's traveling and it connects, and that's how you get those wisps.
Is that the result of a head that needs to be cleaned or adjusting the flow?
Probably has to do with both temperature and what's called retraction. So when the head actually goes from one area to the other where it's not printing, most printers will pull the filament back in a little bit. And sometimes, depending on your settings, you might have to pull it in farther or turn the temperature down a little bit.
All right, I'm going to stop sharing so we can actually discuss it. But, okay, Adam, what do you think? And then how?
I agree with everything Ken said. I would also add that cooling could be a factor. And judging by the surface texture of the print and the color, I have a feeling that this might be a wood-filled PLA filament. And so those...
Did you say wood-filled?
I did. They make wood-filled PLAs, which now that you have a printer at home, you should absolutely pick some up. But it can be a little trickier to print with. It does smell like wood when you're printing with it, which is kind of cool.
That's a benefit, I think.
It's essentially sawdust mixed in the plastic. And so that is mostly an aesthetic thing that you might want for your prints. It can sand a little bit easier, but also the flow out of the nozzle can be a little trickier to work with, which I think could be causing the under extrusion and the stringing that Ken mentioned.
Yeah, usually you have to slow down for those specialty filaments.
Yeah. Just
because it's harder to extrude.
Apart from a more pleasant smell, is there another benefit to the wood filament?
Aesthetics. So it tends to look nice. Anytime you add like carbon fiber or glass fiber or there's even some plant fiber matte, like matte versus glossy filaments, and so those tend to disguise layer lines better than just a pure unfilled plastic.
Got it. Cool.
All right. Are you guys ready for the next one? Oh, sorry.
Sure. Oh, some of the materials, like they even have like bronze fill, which is a metal powder, and when you sand that one back, it actually has kind of a bronze metal look to it.
That's cool.
Very cool. Okay, guys. So the next one. Actually, no, before I show you the next one, let me go back to my screen share. Can I now switch it?
That looks like it was going to be Pumbaa from The Lion King, maybe.
Okay.
Ben, did you guess what it was?
I didn't. I will.
No?
I will give credit where credit is due in the description. So does this make sense then? This is basically what you were talking about, and I think they were guessing also. I don't know if this is actually what happened, but it was their best guess. All right, you guys ready for the next one?
Ready.
All right, I need a drum roll. So I want you to look at it, and then I'm going to go back to us so we can talk about it. All right.
Oh boy.
Yeah.
All right.
Just think about it for a second.
I'll answer first on this one.
Okay.
This is easy.
Okay.
This is one of those classic 3D print failures where the print itself got knocked over on the build plate. This usually happens when there's a really small surface area on your first layer, and then maybe it gets wider at the top of the print, and so there's not enough keeping it in place on the build tray. It falls over, and then the printer just keeps printing in midair, so you end up with just a big bird's nest when you come back to it in the morning. It's very frustrating.
That happened during our stress test, 3 times before you could actually get it printed properly.
Right, because I screwed up the support settings, and so it fell over.
Yep.
That's it. It happens to everybody from time to time.
If it's not from falling over, it's probably from just unsticking from the bed entirely. I've had cases where the whole model will be moving along with the head because it came completely undone from the base.
How do you fix that? Or prevent it?
Better design?
It depends on the printer and your build surface. So, not with printers that we sell, but with at-home printers and cheaper models. There's a big variety of what build plate you're actually printing on and what that surface is. So some of the most popular are build tack surface, which is just a textured plastic that the filament sticks to really nicely. Some people prefer just printing on glass. Some people prefer doing glass plus glue stick or glass plus hairspray.
I was going to say PAM, maybe non-stick cooking spray.
Yeah, that's the opposite of what we want, actually.
That would guarantee
But it'll come off
failure.
easy.
Right, but it'll also never stick to the actual surface. It really there's a lot of variety there. So apart from just looking at the print surface as a whole, what I'd call the Z offset, right? So every printer will have a Z end stop that it'll touch off, and then it uses that location to determine how close or far away from the build plate it should be. And you can adjust that end stop. Some of them it's a physical adjustment, some of them it's adjusted in software, but sometimes you need your nozzle closer or further away to the actual build plate.
Yeah, and with our machines, typically one of 2 things you can do. One be to just recalibrate the layer height. That's usually the easy one. And number 2 is if you have really tall, thin models, you may actually need support to hold that tower up while it's printing. So
you would use surround support instead of most of the default support settings for Stratasys printers.
Not accounting for an overhang or an odd geometry, but just to give it stability.
Yeah.
Breakaways, right? Would they most likely be a breakaway support?
One of the kind of funny challenges with really high-end printers is they go so fast that they can actually knock over small components. So sometimes, either the surround support or even using just a dedicated wall, I know they have wall supports you can use too, they'll hold the model in place while it's printing.
That is good to know. All right, guys. Are you ready for the next one?
Let's go.
I'm anxious for the next one.
Is there an answer for that one?
Yep, I'll go to that.
The last one looked like it could have been an art installation also.
I think it looks nice in a really weird way.
Yeah.
Yep. And you hit the nail on the head
Probably
with
your bad.
not sticking.
Told you, classic spaghetti print. Bird's nest.
So, okay, I was going to say spaghetti because it's sticking to the sauce, and that's where I went to. Spaghetti
Right,
because it looks like spaghetti.
All right, here's the next one. This is a little harder.
Ew.
Ooh.
Give you a few seconds, and then I'll show our screen again. All right. What do you think?
I think Kevin's up, right?
Oh, I don't know. So why don't one of you guys answer?
Ken, this is one that you got to answer first. What do you think? It's okay to be wrong. It's only recorded and distributed across the world.
On the internet, yep.
It's just your reputation.
It looked a little bit at the top like you might have had some layer shifting. It's probably not the worst thing, but...
What's layer shifting, for those who don't know?
It's kind of hard to describe, but basically you print a layer, and then typically with printers that use belt systems, what they might do is when they move real quickly, they may skip a tooth on the gear, and so the head won't actually be where it thinks it is, and it'll actually start printing the exact same pattern, just slightly off-center. And that's how you end up with parts that look like the layers are perfect, but they're all like shifted like a Jenga set almost. Also on that one, probably again, some extrusion problems because you've got really weird, inconsistent layer lines.
Do you guys have like a triage process for when you see problem prints like that? Like, is temperature the first thing you look at, and then the design, and then, some of these other environmental factors?
I don't personally have like a step-by-step process. I just have a lot of experience troubleshooting things where I can look at it and get a pretty good idea.
I'm sure you don't see a lot of that, like something that bad with our printers, though.
No, but at home I see it all the time.
Oh, really?
Yeah, all the time. I've been fighting with my one printer. You can sort of see it right there. I've been fighting with that one for the last 4 days, right? I had a nozzle jam. I tried everything in the book, cleaning filament, cold pulls, hypodermic needle, up the nozzle. Finally just had to bite the bullet and replace the nozzle, and then the thermistor kept popping out, and
Thermistor?
Thermistor, yeah, it's
That's
the
a
temperature
fabulous
sensor in the hot end.
That's
It's
terrific.
a thermal resistor, so it changes in resistance. This isn't what we normally talk about on the podcast.
The word thermistor just got me. I was like, what the hell is that?
I gotcha. Anyway,
but you've seen a lot
of the failed print. I've seen a lot of stuff, Kevin.
Yeah.
I've seen a lot of stuff. I think this print largely boils down to a cooling issue. I'm not 100% committed to that answer, but that's my best guess. I think it could be one of two things. I think the most likely thing is that this person is trying to print ABS material in a non-enclosed printer. And ABS likes to take its time to cool, and when it doesn't have enough time to cool down and settle into its shape, it likes to warp up. And so I think that's what we're seeing on those overhangs of the print, is it's warping up, and then and then the nozzle is kind of dragging along there, and so that's why the print looks a little bit melted. The other possibility is that they're doing PLA or PETG, and they don't have their cooling settings dialed in right. They need more cooling.
You're pretty good at this.
Yeah.
Okay.
Thank you. I hope I'm right.
Are you ready to see the answer? Oh, wait, and Ken, what did you say it was? What was...
I thought it may be a little bit of layer shifting, and then
Okay.
probably some like under extrusion again. Not bad, but definitely there.
Okay. Drum roll.
Am I the only one drum rolling? Is that what's
I hear
happening?
Yes. Yeah. It is audible, yeah.
Layer cooling.
Look at that.
Overheating, and it didn't tell me what the type of material was. Okay. Does that make sense to you? That's basically what you said.
Yeah.
Yeah.
It could have been layer shifting. It could have been a loose belt.
Could it be both?
It could be both.
In theory?
I need
Okay.
more pictures. I need more pictures to determine which one it is.
One thing to keep in mind when you're talking about like examining prints or failed prints, if you're the one that set it up, usually you know what settings were used, and that's a dead giveaway right there. when you walk up and something's wrong if you know how it was supposed to be in the first place.
Mm-hmm.
All right. I'm going to go to the next one now.
Ben, this is fun. I like this game.
I was going to say we should start.
I do too.
We should get people to send us their failed prints and see if we can diagnose it for them.
Yeah, that'd be awesome.
That'd be fun. Ooh.
So just take this in for a minute, and then I'll gather your thoughts, and then tell me about it. You ready?
Ready.
Okay. What was that?
That was a printer that caught fire. So, in case you couldn't tell.
That's pretty, that's low-hanging fruit.
Yeah, Ken, you're getting all the hard ones.
By the way, that was from an article. That was from
Why
an article.
did it catch fire?
Yeah, what would make a printer catch fire?
That news article, by the way, was, is your 3D printer trying to kill you?
That is a clickbaity title.
Yeah, right.
So, on all 3D printers, especially common hobby 3D printers, this is really important. It has a setting in the firmware on the machine called thermal runaway. And what that does is if anything happens to the wiring on the printer, it'll shut itself off completely. That way it doesn't accidentally keep heating and overheating. I just talked 2 minutes ago about the thermistor on my printer having issues, and it kept coming out. If thermal runaway was disabled on my printer, the printer would just keep heating. It wouldn't know how hot it was, and eventually it would catch on fire or it would short out and break the wires, which can be very bad. This has been a controversial issue. You heard in the 3D printing community for quite a while, because most printers at the hobby level and even somewhat at the prosumer semi-professional level pretty much all run the same firmware. It's called Marlin, and by default in the configuration, thermal runaway is turned on. But for a long time with the really cheap printers, they didn't have very high quality components that could heat up quickly. And so what the manufacturers did was they actually turned off this setting to help the printers heat up more quickly. And then if the thermistor failed or it came out of the hot end for any reason, the printer catches on fire.
That sounds like a safety answer.
The biggest issue with that was you didn't know. Unless you went into your printer's firmware, you would never know if it was turned on. So it became a thing for a while that if you bought a super cheap 3D printer, or even those lower level prosumers, really push people to go and look at the firmware to make sure that's active. It seems like now most of the major manufacturers have figured it out. I would still check, but the people at least in this picture you showed, that company I know has switched to permanently putting it on.
Now, why does turning it on slow down the heat up time?
It shouldn't. It's really just a testament to how cheap the components were.
Yeah, I thought also part of the issue was like the sensor couldn't accurately read the temperature. So, like if let's say we're trying to get to 200 Celsius, the thermistor may spike and accidentally read 240, which is way out of the range, and it would immediately kill the printer.
Right.
Like just turn everything off. So it wasn't it was doing what it was intended to do, but because the thermistor was so low quality, every time you would try and turn on your printer, it would just say, "Oh, it failed. It overheated."
I see how that could get annoying.
Mm-hmm.
Yeah.
I also see how your house being burned down would be annoying too, though.
That'd be worse. Yeah.
I'm guilty of, with my first printer, I always had it turned off. Just wasn't worth it.
Yeah.
Because of the temperature reading fluctuations. What it does is you can go in the firmware and set it like every 3 seconds, check the temperature, and you can change that number. If it's plus or minus 5 degrees, then you're fine. And again, you can change that degree tolerance. Sometimes it's easier just to turn it off.
Makes sense.
All right, so you totally got that one right. Let me go back to the slideshow. So you got that right. Yep. By the way, I had to choose between either this one or I found a bunch of 3D printers that would like throw themselves off of the table. And
What?
Off the
I thought
table.
that was I thought that was pretty funny. There were like two issues for it. It's like you didn't secure your printer down, and like when it moved, it would like slowly creep over to the side of the table until it would eventually kill itself. Or like the filament was attached over here and it wasn't releasing fast enough. And so if your filament was away from the table, it would just pull itself and
spooling
then kill
off
itself.
and just pulling it with it.
So my first printer, I walked in one time because the filament was bolted to the wall. There was a spool on the wall, and it got basically coiled on itself, so it wouldn't spin anymore. So the printer actually raised itself up. The gears were strong enough to raise the entire printer up to the top of the filament before it stopped. It got jammed.
It tried to hang itself.
It was a really light, little, tiny printer, but I just walked in and I was like, okay, this isn't right. Why is it floating?
Yeah, your printer should never be like swinging around, right? Especially during a print.
Not ideally.
Oh boy. All right, on to
You
the
want a
next
stable
one.
surface. Ooh.
The curveball.
It looks like it's growing something.
Yeah. I believe this is the same print, and then they painted the bottom.
Okay.
Yeah. Because you can kind of see the yellow going through the green. I think. So my two questions for you. Why are the two prints different colors? Do you think they tried to paint it, or is that on purpose? And also, how the heck did they get it to go that far in one direction with no support material and then straight up? The curveball.
This
do you know?
is definitely a curveball.
How do you know
What do you
they didn't
think?
use support material?
Oh,
Could have just broken it away afterwards.
Well, according to this article or list, I forgot where I found this one, there was no support material, apparently. So just going off of that, just whether or not it's true, if there was no support material used, how was it done? Or is it just
I
not
think this
possible?
is Sorry, who's talking?
The delay,
I
man.
think this is a layer shift. I do. I think
That
a
bad?
couple key factors here. It's all in one direction, which indicates that one of the motors probably failed or overheated and stalled. That's a common reason why a layer shift might happen. It was able to print in midair like that because it looks like it did a circle and then went up to the next layer and did a circle. And so you essentially got kind of like a stair-stepping technique followed by a ton of cooling because it looks like it was supposed to be like a thin cylinder that came out of that part. And so the cooling would have been turned up quite a bit on that thin feature. And so you were able to just kind of keep stair-stepping even though the motor failed. And then either the motor cooled down enough to recover so that it could keep printing up in kind of a cylinder shape like it was supposed to. It's probably my best guess.
Very believable.
Could you go back to the picture real quick?
Yeah, sure. Nothing's fast.
You
It
sold
could
me on
also-
that explanation, Adam, because it looked like it was growing something to me.
It could also be different colors because this could be thermochromic filament that changes color dependent on temperature. And so at elevated temperatures it would be yellow, and at lower temperatures it would be green. So I think in the picture on the desk it had freshly come off the build tray and the yellow part is still a little bit warm. Versus in the picture on the right, the whole thing's warm because it has a heated bed.
I can't remember the name. When I was applying to colleges, I think it's the New York School of Arts or Fine Arts, whatever it was, and they sent me their packet, and it had that material on the top of their packet. And when you put your hand on it, then a map of New York City showed behind it. and then there was like a piece of artwork in front of it.
That's
it was
cool.
So cool. I kept
That's
it for so
awesome.
long. I had no intention of even going there, and I'd be like, "Oh, look, it's my face in New York City."
It's like a mood ring, you know?
Yeah.
That's cool.
Okay, Ken.
Yeah, I don't know. I don't know if it was layer shifting because like the distance it went was so long and such a short height. That's why I'm a little confused because
Wind.
If it did layer shift, it would like incrementally move up. And because that cylinder was so tiny, I'd be amazed that it went that far in that short amount of distance. I don't know. The color changing makes sense, like the different temperature to get different color.
What was that called? Thermochromic?
Yep.
I don't know about the tab. Yeah.
What's
I would love to
what's
see
the
the
answer
file.
here, Ben?
All right, let me pull it back up.
Inquiring minds need to know.
Oh, come on.
Wait a minute.
The only guess that this article had was basically word for word what Adam said. And I was very impressed. I almost thought you wrote the article. So it talked about it had to have been a really cold room, and the glass would have helped, so it would have been able to cool fast enough for it to not need supports. And it really talked about temperature a lot, and then they said after that, I just want to see the file. I have no idea. So I think Adam has the best guess because he guessed exactly what they said and then some. Made sense to me.
Did it not look like an injection mold, though? Like a housing for an injection mold? Why would you want, like, what would you be making that you would want that thermo
It looks
reaction?
I think mostly...
Thermochromic, right? Did I get it right?
Yeah.
Okay.
Look at us, dropping all sorts
That's my SAT word for the week right there. That's a good one.
I think it's mostly like a gimmick. I don't know of any like practical industrial applications using thermochromic materials, but that's just
I was just
me.
curious. Yeah, I didn't know if maybe, tracking if it was, warm in the room and you'd look to see what color it is. I don't know.
I
Your
think
coffee
it's mostly
cups. Your coffee cups have it, like different
Sure.
things. It's mostly a gag gift, or to try to get kids to apply to their school, I guess.
Yeah, I've seen.
My kids have it on a
filaments-
pencil.
Yep.
I've seen filaments that like change color when they're heated differently. So like if you put it in the fridge or if you just hold it in your hand for a while, it'll change color. But I've yet to come across anyone that needs the filament on its own to change colors midway through the print instead of just stopping and changing the color of the filament.
And you wouldn't use like fill material, like you wouldn't waste that on the inside where it's not going to get exposed. So I don't know, odd application maybe.
I also have seen UV reactive filaments where, like, if you have it inside, it's white, and if you take it outside, it turns pink. Like, it's neat, but I don't know of anyone using it for practical things.
Yeah. Well, there's got to be a use case somewhere, I'm sure.
Yeah, you see that
Maybe.
in glasses where basically they're never fully dark outside and they're never fully opaque inside, and so you just have people with bad eyesight that are having a really hard time wherever they are.
What?
That's not the point of glasses.
Yeah, you know the lenses that react to light. Yeah.
Transition ones.
Transition. Yep. Maybe that's different, but anyway, that's all I had for you. One curveball. I had a lot of fun finding those images too.
That was fun. I think next time we need to keep it to like 3 pictures though, because that segment took up way too much of our podcast. But it was fun.
I was gonna do 10, and I thought, maybe 5 is all we need. That'll be pretty quick. Apparently
Well,
not.
now we know. Knowing's half the battle.